Question number 76. Liquefaction isotherm of carbon dioxide is given as we have this graph in which certain isotherms are there. These are plotted between pressure and volume, and we have this TC value that is 30.98 degrees Celsius. This is the critical temperature for carbon dioxide gas, and we all know that critical temperature is that temperature above which a gas cannot be liquefied whatever be the amount of pressure applied. So we have different statements and we have to select the incorrect statement among the following. Let's check the statements given here. At point C, we are talking about the point C, physical properties of liquid and gas are same. If we talk about this curve, you should always know that at below this curve, this gas and liquid phase coexist. And if we talk about at point C, this is the point C, physical properties of liquid and gas are same. It is a correct statement. Further, at temperature T2 and pressure PC, PC is the critical pressure, liquid phase exists. We're talking about the temperature T2, there is the isotherm which is given, and pressure is PC. PC is the critical pressure. So we're talking about this isotherm, and this is the point at which we are talking about. At this point, liquid phase exists. So that's why this statement is also correct. Further, at temperature TC, that's a critical temperature, and pressure P2, this is TC, critical temperature, and pressure is P2. Liquid phase exists. At this point, if we talk about P2 and critical temperature is given here, at which liquid phase does not exist. That's why the statement is wrong. At point C, liquefaction of gas is possible. We are talking about the point C. Yes, this is the point at which liquefaction of gas can occur, and that's why this is also the correct statement. Now, on the basis of this, which statement is incorrect? Statement 3 is the incorrect statement. Now, let's move on to the next question. Question number 77. 0.48 gram of a volatile substance upon vaporization gives 112 ml vapors at STP. Ratio of rate of diffusion of vapors of volatile substance to H2 is. Assume vapors behave ideally. So we are assuming that we are talking about the ideal gas, and we just have to find out the ratio of rate of diffusion of vapors of volatile substance to hydrogen gas. So first we have 0.48 gram of volatile substance. Its amount is given and the volume of its vapor is also given. With the help of this, we can find out the moles of the volatile substance. That is equal to given volume 112 divided by 22400. So the number of moles would be 1 by 200 moles. These are the moles of that volatile substance. We know the mass of that volatile substance, moles we have, so we can find out the molar mass of the substance would be equal to the given mass 0.48 divided by 1 divided by 200, because the moles are 1 by 200. That's why the molar mass is 96 gram per mole. This is the molar mass. Now, we just have to find out the ratio of rate of diffusion of vapors of volatile substance to H2. And we know that rate of diffusion of volatile substance, I'm taking here as RV divided by RH2, would be equal to root of MH2, molar mass of hydrogen, divided by molar mass of that volatile substance. So that would be equal to root of 2 divided by 96, and it would be equal to 1 by 4 root 3. And where it is given? It's given in option 2. That's why this is the correct answer for this particular question. After this, it's a turn for next question. Now we have question number 78. Compressibility factor Z for hydrogen gas at STP is. Now first question is that what is this Z value? This Z value is the ratio of PV to RT for 1 mole of the gas. Now we should know that this hydrogen is a real gas. So in this case, we follow always the real gas equation, that is, this is the expression for pressure, and after volume correction this becomes B and it should be equal to RT. Now one more thing you should know, that for hydrogen gas, A value is almost negligible, and if it is so, we can easily find out that P into Vm minus B is equal to RT. So we can also write it like PVm minus PB is equals to RT, and in this case the value of this PVm becomes RT plus PB. Now just take this value and place this in the first equation that we considered here. This was the first equation that we considered. So this Z value is equal to RT plus PB divided by RT. So it would be equal to 1 plus PB upon RT. This would be the value, and where this value is given, if you check here the given option, you will identify this. This is given in option 4. And one more clear hint is there, that whenever we talk about hydrogen or helium like gases, always the Z value is more than 1, and the expression we have find out here. So the answer is option 4. I hope this question is clear to you. Now let's move on to the next question.
Now here is question number 79. In a container of 10 liter volume, 20 gram oxygen gas, 2.8 gram carbon monoxide gas are taken at a total pressure of 2 atmosphere and 27 degrees Celsius. Partial pressure and partial volume occupied by oxygen gas in container respectively are. So in this case, we just have to find out the partial pressure as well as the partial volume. We know that if we talk about the partial pressure of a gas, that you can find out by considering its total pressure and multiplying it with the mole fraction of that gas. Then you can find out the partial pressure. So first we have to find out the partial pressure of oxygen. So let's assume that partial pressure for oxygen is PO2, and before that we have to find out the mole fraction, because in this case we have 20 gram of oxygen and 2.8 gram of carbon monoxide that is given. So with the help of that we can find out the mole fraction of oxygen, that would be equal to the moles of oxygen, these are 20 by 32 moles of oxygen, divided by the total moles present in the mixture. So here are 2.8 gram carbon monoxide, given mass of carbon monoxide divided by its molar mass, and if you solve this you will find out that mole fraction of oxygen in this mixture is 25 upon 29. This is the mole fraction of oxygen. With the help of this we can easily find out the partial pressure of oxygen, that is equal to P total. What is P total? That's given here. If you check here, the P total is 2 atmosphere, and we can write here 2 into 25 upon 29, and if you solve this, this would be 50 upon 29 atmosphere. This is the partial pressure of oxygen. The next thing that you have to solve here is the partial volume of oxygen. The two things which we have to find out, partial pressure and partial volume of oxygen. So in the similar way, if we talk about the partial volume of oxygen, that would be equal to the total volume into mole fraction. So what is the total volume? We should know that total volume is given here, that is 10 liter, and on that basis 10 into the mole fraction, that is 25 by 29, and it would be 250 upon 29, and this is in liter. Now we have partial volume as well as partial pressure. We can easily choose the correct answer, that's given in option 1, And that's why I mark here the correct answer, that's option 1. I hope this question is clear to you. Now let's move on to the next question.
Now question number 80. At 273 Kelvin, ice and water are in equilibrium and enthalpy of fusion of ice is 6 into 10 raised to the power 3 joule per mole. The values of delta S and delta G for conversion of 1 mole of ice into water respectively are. So if we talk about delta S value, that delta S value is equal to N into delta H, enthalpy of fusion, divided by the temperature of fusion. Just recall what's the temperature of fusion, that is 273 Kelvin. So this delta S for the conversion of 1 mole of ice into water would be, so here the number of moles 1 mole and the value of delta H fusion, that's given here 6 into 10 raised to the power 3 joule per mole, divided by its temperature, that is 273. And if you solve this out, this would be 21.98 joule per mole per Kelvin. This is the value for delta S. And if we talk about this delta G value, because we are talking about equilibrium condition, so definitely this delta G value is 0. And if we have both the values of delta G and delta S, we can easily choose the correct answer. Delta S and delta G, that is 21.98, and 0 is given in option 3. That's why the answer is option 3.